What's up guys, Shawnthebro here, and today we're going to be going over advanced wall bouncing and ground bouncing mechanics. So they're going to be pretty simple mechanics, believe it or not, but we are going to be adding this behavior to the bounces we already have, because we have wall bouncing and we have ground bouncing. However, they're a little bit janky right now. If you try and use them and you, for example, use the wall bounce, the character that is bounced will bounce into the attacker character. And in doing this, this can force the character to be stopped against the attacker. And so we don't want that. We want the wall bouncer to phase through like this, okay? That was a little close, so it might have looked a little weird. Let's back up a bit. You'll be able to see it a little bit better. So if I am to throw the opponent into the wall here, they will bounce and phase through the character. They will also not be able to get stuck in the character. Same with the jumping logic, how we have a little slide effect. We want to make sure that we don't have any characters getting stuck inside of each other. Nothing like that. Now, same goes for the other side. So if I am to bounce my opponent, that is certainly the wrong input. If I am to bounce my opponent into the left side wall, then they also phase through. So they can now phase to the other side. Understand that doing this, if I am to, let's flip these around actually, do this. This does not mean I cannot still hit my opponent, because I absolutely can. Well, if I was better at my own game, I might be able to. So let's see if we can launch our opponent. And we can still hit them and trigger collisions with them off of the wall bounce. We're just ignoring collision between the actual collision components on the characters, so like the push boxes and such. Alright, now let's look at the other example. Let's look at the ground bounce example. Okay, so if I am to use this move, I cause the character to ground bounce. I can then walk under them. Okay, I have a brief moment in time. This bounce does enough bounce that I can walk under the character while I'm doing that. Now, if I were to do this and say I did not do that correctly, and I got stuck in the center of the character, currently in the series, the character that got ground bounce would be stuck on the player's head because of the same logic as before, where we don't do any logic for checking if the characters are stuck inside of each other. So all that logic we did with the jump is only on the jump. But we can use that logic that we had to smoothly move the characters off of each other's heads to also avoid getting stuck off of a wall bounce and a ground bounce. And this makes it just much, much cleaner, because we're never getting stuck inside of each other at this point. Okay, so that's what we're going to be covering today. Before we hop into it, if you'd like to get caught up in the series, this is episode 149 of the Fighting Game Tutorial series. We still have a long way to go, but we've come so far, and I'm really happy with how far we've gotten. If you want to check it out, leave the playlist in the top right corner right here. You can check out every episode we've done to get to this point. Alternatively, if you'd like to get caught up on the wall bouncing, ground bouncing mechanics that we will be using in today's episode, feel free to click this episode right here. This is where we first covered the wall bouncing. Otherwise, we can go ahead and get started. So like I said, today is actually going to be pretty simple in terms of the logic we do, but it's really important. They're small changes, but they're very important changes, because otherwise the wall bounce and the ground bounce can both lead to the characters being stuck inside of each other, which is immediately a soft lock, or at least a very undesirable result. But these small fixes can update that and make it where that doesn't happen. So we need to go to our camera edge. Now our camera edge we have not messed with in a bit, but it is this rectangular object, and it's basically just a border for how far out you can go on each map. Alright, so if we load up an example here, we will go on, let's just go on the side scroller stage, because I think it's the easiest to see and test things on this stage. Alright, so we have these inner boundaries here where both characters are at the edge of the screen. However, if one character moves closer to the other, we can move farther in that direction. For example, if my player on the left moves more to the right, then my player on the right can move more to the right as well. Right? We have a maximum distance apart, But we also have actual map boundaries. Like this is as far as we can go to the right, and this is as far as we can go to the left, and that's intentional. Now, the characters can wall bounce off each of those. You saw me causing the wall bounce off of the outer boundary, but we also have this inner boundary that I can cause a wall bounce from, like that. The fireball causes wall bounce, so you can see that the mutant did bounce off of the wall. Okay, it did not have a lot of force, so it knocked him back. He came back afterward, but you can bounce off the inner boundaries in this scenario, in this game. And so the camera edge, that's what it represents. It represents both the inner boundaries and the outer boundaries. So just take note of that because that's important. Now in here, all we really have is if a component is hit and it's a character, and the character is in the launch state, we want to wall bounce them in the appropriate direction. Launching a character with a force or with a velocity based on the direction they're facing, setting their state to be wall bounced. Now I'm adding one additional node here. That's all we're doing in this file. Everything else has already been set up. I'm just adding this one node. And you might recognize this one, ignore player-to-player collision. Do you remember that? That's what we set up in the fighter template character for, again, the jumping. This is because we want the characters to be able to jump on top of each other and slide off. We don't want them getting stuck. We don't want them standing on each other's heads. And so we set this up. However, we never used it for anything else outside of the jumping. We can use it for the wall bouncing logic. Alright, so this casted object here is a fighter template character. So we will be able to call our ignore player-to-player collision, assuming we have it as blueprint callable. Right here it's blueprint implementable event and blueprint callable. So you can see that I do have it here. And there you go. Just a refresher on what this actually is, because it has been a while. We go into our base character BP. And if we go to our ignore logic, ignore player-to-player collision. If we're turning ignore on, we set the pawns to overlap each other for their collision boxes, meaning they won't collide with each other, but they can still get hit with the hitboxes and everything, as I showed you earlier. We set both of the characters like this. If we disable should ignore, we set them both to block. Okay, that's all we're doing here. So we're saying if one's in the wall bounce state, we don't want to be able to block each other. We want to make sure that the wall bounce character can phase through the other character. All right, so I have a bunch of reroute nodes, but literally if you just drag off this and type should or ignore player-to-player collision, just like this, and then check should ignore to ignore it, you'll get this node, and we'll be good with the camera edge. That's actually all you have to do. Okay, now there's more we have to do in code, but that's the one thing we had to do in the blueprint because we had to do it upon collision with the camera edge or the camera boundary. So now if we go into our code and we can go to our fighter template character or our base character.cpp, we want to scroll down until we get to the logic for landed. Now for me that is right here, landed. You can also search for it with Control F and just type landed. But here's the logic that we have, and what we were doing is we were checking to see if we were jumping, you know, either a directional jump or a standard jump, and what happens when we landed. So if we landed on another player, we did our slide off logic. Else if we didn't land on another player but we didn't land on a hitbox, then we did this logic to reset the data that we had, so our gravity scale, our modifier, our character state. Then if we're in a combo state, we did additional stuff. So we may have forced the character to enter the knockdown state. We may have set the character to begin their ground bounce logic, whatever it may be. We have to add more in here though, because what we had this else if statement, checking to see if the combo state was launched, so if the character was launched and they shouldn't ground bounce, or it's a wall bounce or it is a ground bounce. So there's 3 different scenarios which all lead to the same state here. Now in here, we were also making sure that we did not collide with a hitbox actor. If we collide with a hitbox actor, we're landing on a hitbox, we're going to apply that launch, we're going to apply that logic. That's when we get into more advanced logic with our air combat and our combat flow coming soon, so don't worry. But right now, all we're checking to see is if we did not land on a hitbox actor. Now, assuming we didn't, we were resetting the gravity scale and the gravity scale modifier. What we're doing in this section here is we're checking the combo state to see if it's wall bounce or ground bounce. The above else if does check for both of these already, so we can enter it, but we do have another condition that would allow us to enter it, and we would not be in the wall bounce or the ground bounce state. So either break these if statements out into other else ifs, or just include it in here like I did. It is a little repetitive to include it in here. However, the rest of the logic is going to be similar, in fact exactly the same, regardless of their states, if they're launched, wall bounce, or ground bounce. And so this additional check just kind of separates this logic to make it unique. So if we are in the wall bounce or the ground bounce state, we want to make sure we are not stuck in the other character. Again, we did this sort of logic for the jumping, and I can show you that. So if you remember in the base character BP, we did it in Blueprint before, we're going to do it in code today. What we had done was we had this move character smoothly to force the character on the other's head kind of down and on the appropriate side, as naturally looking as possible. And a lot of you that have shown me yours, you've gotten it to work a lot better, a lot nicer looking than mine was. But what we were doing is moving the characters to the appropriate position, and then if they are still overlapping each other, we're saying we are stuck. Otherwise, we put the blocking collision back. That way the characters no longer can walk through each other and face through each other. If we were stuck, we went into our tick function, which for me is all the way at the bottom, and we did this logic right here. So if we were stuck, we got the distance apart that we were, grabbed the appropriate distance to move based on some arbitrary values I decided that were good, as well as the actual sizes of the capsules of the characters. Then we moved them the appropriate direction, and then set the collision to be blocking, and reset this variable so we weren't just always pushing the characters out of each other. Well, again, we set the is stuck an enemy in Blueprint because this is where we did the timeline, and we had all this other logic in here, so of course we did it in Blueprint. It made sense at the time. However, we can actually do this in code as well, and if we do it in code, we can use it for a lot more reasons. So we're going to want to use it for both our ground bounce and wall bounce to make sure if the bounce forces the character to be on the other character or inside of the other character, stuck in them, we can force them out of each other. So we're going to go back up to our landed function, what we were just talking about before this. And we're going to go back to this statement here. So like I said, we're checking if the combo state is equal to wall bounce or ground bounce at this point, and then we have to determine if we are stuck inside the other character. Now we never had this function yet, so we have to make it. Let's go to fighter template character.h, scroll down to where your functions are. For me, I put check stuck another character, somewhat close to my other functions. Right here, check stuck another character. And basically, it's just, I made it blueprint callable in case we ever have to use it in the future. It's just void, and then the name of the function you want. We don't have any parameters in this one. It's going to be the same operation we perform every time. We're just going to see if we're stuck inside the other character because both the characters are overlapping or blocking in the same space. Okay. You could return a boolean here to say if you're stuck or not, but we already have that boolean is stuck an enemy that I was just showing you in tick. And so we're just going to set that inside of that function. So if you write this if statement and then call your new function in here, we'll go and fill out the other function now. So let's scroll down. So here's check stuck another character. So I have a method here of determining if we are stuck within another character. And this can be used for the jumping as well, just for the record. You could actually use it in place of this. So this function is going to do the same thing that we did in our blueprint class, like I was just telling you about. So where we were determining if the other player is overlapping us, that's what we're trying to figure out, except we're going to do it even better in the code class here. So we're going to grab an array of all overlapping actors, or really we're making an array right now of all the overlapping actors, and then we're going to fill it out with any that we find. If they happen to be the right type, such as a fighter template character, then we'll know that we are stuck within that character, or at least that's how we're envisioning it. It is technically possible to be overlapping another character, not actually be stuck in them, but we're going to just assume that we are in this case, because if you've, a lot of fighting games, they just push them out regardless. Doesn't necessarily mean you can't move, you're completely blocked, but there's no reason to also be that close to each other or where the characters are clipping through each other. So we're just going to do it regardless. So we make a T array of A actor pointers, and I called it overlapping actors. Again, this is empty, but this is just a container. There's a function in Unreal called getOverlappingActors. GetOverlappingActors takes in an array of actors, and then you can also apply a filter by the class. So if you search for this function, getOverlappingActors, it will come up. And then you have to pass it the array that you're trying to fill out. You do not have to give it a default parameter. This is a filter. So this means that it will only return objects of this class in here. I recommend you do this because if you don't do this, then you can get a lot of actors. I could be overlapping with, this cube in the scene. I could be overlapping with this projectile. I could be overlapping with this hitbox, and all those things. We don't want to try and push the hitbox away from the character and all that stuff. We only want to determine if we're overlapping another character. So for this function, we pass it the array we just made, because this is actually going to return the elements that we are overlapping into this array. That's why we made this array up above. So just pass this in. This function will fill it out for you. If you put a comma, then the name of the class, so fighter template character, and remember it's an actor, so it's a fighter template character. : static class, because we have to pass the class type for the filter, not a specific object reference. If you do this, this will only return the overlapping actors that are of type a fighter template character. Now, even when we get into tag matches and things like that, everyone is still going to be a fighter template character. So this will return all the overlapping actors of that type, and that's what we want. Now we want to loop through all of these because, again, it could be more than one, right? We could have one character that's an assist. We could have our actual enemy. We could have a minion character. Whatever the case may be, we may very well have things that more than one object that we're overlapping with. So we want to loop through all of our overlapping actors starting at I, checking that I is less than overlappingactors.num, and then incrementing I. Then we're going to see if we can grab the individual actor that we're overlapping with. So even though we applied the filter here, you do still have to cast to the type, because getOverlappingActors actually just returns an array of actors. That's why we made this an array of actor pointers instead of fighter template character pointers. So it does still filter out by this class, but it can only have one return type, so it just returns default actors. All right, so when we're in our loop, we now need to make another if statement to make sure that we can cast and grab the appropriate value. So we can do if, you can use auto if you'd like, or you could put a fighter template character pointer here, or just a fighter template character. Then you could name it. I called it overlapping character, and I cast to a fighter template character for the specific object that we want. We're trying to cast overlapping actors at index I. Okay, so we know that we're overlapping at this point. So if we're overlapping and it's a fighter template character, then we're just going to say we're stuck in enemy. We're just making that assumption. We're also going to mark the overlapping character as stuck in enemy as well. This is, again, because of tick. Because tick checks this boolean to determine if we should move the characters apart. And so by setting them both in there, we move them both apart. Now, technically, tick does move each character if either of the characters are marked as stuck in the enemy. So you don't have to set them both. However, setting them both just makes it a surefire way that these characters will be moved outside of each other. And honestly, it looks really natural. It looks just like you see in other fighting games where they just move apart from each other, because really that's all they're doing. They're being moved outside of each other. So once we have this, we know that we can determine that the characters are stuck inside of each other, and the logic and tick will actually cover all of our bases there. It'll solve any problems with being stuck that we have, except it won't deal with the actual collision. So if the characters are stuck inside of each other and they're on a blocking collision, well, they're still not going to be able to move outside of each other because block is going to stop that from happening. So we do still have to manually set the ignore player-to-player collision in their correct spots. Now, for the wall bounce, we already did that, right? For the camera edge, we have it to where ignore player-to-player collision is true when in the wall bounce state. So we have to make sure we reset that. Now, regardless of what state we were in, wall bounce, ground bounce, launch, we want to make sure that when we've landed and we haven't landed on a hitbox, we're not being launched again, we can resume player-to-player collision. We want to make sure that this collision does come back. If we don't do this, sure, we can phase through each other when we're wall bouncing or when we're ground bouncing, but then the characters will just be able to walk through each other as well. Okay? So we want to make sure we call ignore player-to-player collision now and set it to false, meaning that we return it to the standard blocking collision. I do this after all these checks to make sure we can move the characters outside of each other before re-enabling the collision. And that makes our lives a lot easier. Now we had another else if here, which is if we should ground bounce. Should ground bounce is a boolean on this character that determines when they're next able to, perhaps after their current animation, or if they're in a certain combo state, they should now enter the ground bounce state, because they've been hit by a move or a command that can trigger the ground bounce combo state. So in here, we were setting the combo state to ground bounce, and we were resetting the jump count, both things we still want to do. But there's one other thing we want to do in here, and that is we want to ignore the player-to-player collision by setting the boolean inside to true, just like we did in the wall bounce, right? In the wall bounce, we ignore collision when we collide with the wall. However, on the ground bounce, we don't have that luxury, so we have to ignore the collision as soon as we enter the state. There's no other time to do it. When we enter the ground bounce state, we want to ignore collision. Again, if you didn't do this, then when I did this attack, I would be able to land on my opponent's head just like that. He was clearly on top of the other mutant, and thus he would be stuck inside of him when he is trying to fall back down to the ground. And again, with the wall bounce, if I hit this opponent into the wall, if I do it a little bit better than that, you can see the opponent that was wall bounced was able to go through the standing opponent on the ground, as opposed to landing on their head or being stuck inside of their feet when they phase through them. Instead, they just move out peacefully, and you don't ever see any issues. The blocking collision is returned right upon landing, so they're already phased out, and at that point, you're able to just do all your normal behavior. Now, there is one other thing we can do to clean up. So in our base character BP, now that we do have this new function, this check stuck another character, and I had made it blueprint callable, you can actually use that now instead of doing this logic if you'd like. So when it's finished, you could check stuck another collision, or check stuck another character, excuse me. And if you, instead of using this other player is overlapping actor, you could get rid of this to make it better, because again, we may have more than one character, especially in tag matches. And instead what we could do is we don't need to set is stuck an enemy to be true anymore, because it's going to be set in here. But if we grab is stuck in enemy as the branch, if it's false, we don't want to ignore collision, right? But if it's true, we can do nothing, because we know that we're stuck in the enemy, and we know that tick is going to take care of it. So now if I compile and save this, and we play our game, I can now jump on each other's heads, just like this, and move to the appropriate spot. It will work every time, the same as it did before. But now we're not just checking other player, which is better, and now we're using more of our code dependencies, which is also better. We want to use code as often as we can because there's so many things we can do in code and so many things we're going to have to do in code. And we don't want to have a bunch of blueprint dependencies that are the same as our code dependencies, right? If we already have a function for it here, we should just do it here. Now, if you wanted to, you could even start filling out this logic in code as well and get rid of some of this blueprint. But again, I'm okay with this. I just wanted to show you there's no reason to, reinvent the wheel, right? We already invented this function. So we might as well just use this function as opposed to using the other logic that we had that was kind of hard-coded and not related to anything else. This will also factor in other characters, not just other player, but tag matches and minions and things like that. So all around, this is just better. Lastly, I'd like to fix up a bug that was reported to me when upgrading to Unreal Engine 5.1. So this might happen to some, it might not happen to everyone. Some people reported it, some did not. But in our base game instance, if you've been following the series, we had overridden the init function. And here it is in the header file. And if I go in my C++ file, you can see that I have it right here. And we have this fcore delegates on controller function. We should add super : init to make sure that the base game instance init function is functioning properly and that it does everything that is now included in the parent game instance class. If you don't do this, you may have issues with widgets popping up on your main menu level. This should solve that issue. I'll explain more when we upgrade to that version because there are a few other additional changes we can use to make our lives easier. Anyway, guys, that's all I got for you today, so thank you so much for watching. If you enjoyed, please subscribe. That's more for myself and the channel than anything else you can do. I just really appreciate it. I want to give a huge shout out to my YouTube membership and Patreon members and supporters. Thank you guys for all the love and support. I'm incredibly grateful and very, very excited to keep working on this project and game with you guys. This is so incredibly fun, and I'm glad you guys are as excited as I am. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. I'd be happy to assist you, get you set up and continuing on your game. It's completely free. Otherwise, guys, like I said, that's all I got for you. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.